Have you ever looked at a software project and just wondered why some of them are pure magic while others, well, they just crash and burn into a huge pile of wasted time and money? The secret, a lot of the time, isn't in the code. It's in the blueprint. Today, we're going to pull back the curtain on software requirements engineering, the hidden discipline that really decides if a project is going to be a spectacular success or a complete disaster.
All right, let's just start with a number that should really make you sit up and pay attention. 100 times. That is how much more it costs to fix a mistake late in a project, after the code's all written and out there, compared to catching it right at the very beginning. Seriously, it's the difference between just erasing a line on a piece of paper versus demolishing a wall in a house that's already built.
And if that didn't get you, get this. Somewhere between 40 and 60% of all project failures can be traced back to just one root cause: bad requirements. That's almost half of all the projects that fail. It's not because the programmers were bad. It's because the plan was broken from the start.
So you see, this isn't just some small technical issue, it's a massive business crisis. Getting the requirements wrong is kind of like setting sail in a boat with no map and no destination. You're just going to burn through a ton of fuel, make your whole crew miserable, and you'll probably end up wrecked on an island you never even wanted to visit.
And when you look at the wreckage, the causes are almost always the usual suspects. You've got ambiguity, where nobody's really 100% sure what they're supposed to be building. Then there's the dreaded scope creep, right? That endless, oh, can we just add one more thing? You've got poor communication, where the left hand has no idea what the right hand is doing. And maybe the worst of all, stakeholder absence, where the people who actually need to make the decisions are nowhere to be found. Each one of these is just another crack in the project's foundation.
So the big question is, how do we stop the chaos? Well, it's simple, but not easy. We create a rock-solid blueprint. In the software world, that blueprint has a name: Software Requirements Engineering, or SRE. It's the whole disciplined process that takes these fuzzy, vague ideas and turns them into a concrete plan that actually leads to success. Okay, I know. That definition sounds super academic and a little dry, but let's break down what it really means. It's all the work you do up front to create this crystal clear, shared understanding of what you're building before anyone even thinks about writing a single line of code. It's about getting everybody in the room looking at the same map and pointing in the exact same direction. And maybe the most important way to think about it is this: SRE is the bridge. It connects the world of business, what the company needs, what the customer wants, with the world of tech, what the developers are actually going to build. If you don't have that bridge, you've just got two groups of people shouting at each other across a canyon. It just doesn't work. So, what does building this bridge actually involve? Well, it's a very structured process. Think of it like an architect designing a skyscraper. You don't just show up with a crane and start throwing up steel beams, right? No, you follow these very deliberate steps to make sure the foundation is solid and the vision is perfectly clear.
The whole thing really boils down to these 5 main activities. It's a journey from a raw idea to a solid plan. First, we have elicitation to figure out the needs. Then analysis and specification to sharpen and document them. After that, validation to double-check everything, and all along the way, management to handle changes. So let's just quickly walk through each one.
First up, elicitation. This is basically the detective phase. You're not just sitting there asking people, so what do you want? You're digging deeper. You're using interviews, workshops. You're even just watching people work to uncover what they truly need. Because a lot of the time, users don't even know how to ask for the thing that will solve their problem. It's your job to uncover it.
Okay, next up is analysis and negotiation. This is where you have to face the fact that almost every project has built-in conflicts. Just look at this Uber example. The driver wants the highest commission possible. The customer wants the lowest fare possible. And the company, well, it needs to make a profit. They can't all get exactly what they want. The analysis phase is where you play diplomat. You find these conflicts and you negotiate a balance that actually works for everybody.
So once you know what to build, you have to write it all down. And you have to be incredibly clear. This is specification. And it is so important here to separate the functional requirements, what the system has to do, like letting a user log in, from the non-functional ones, which is how well it has to do it. A login page that works but takes 30 seconds to load is functionally correct, but it's totally useless. Ignoring the non-functional stuff is a classic mistake.
Now, before you give that blueprint to the builders, there is one last, crucial quality check: validation. Is this plan actually correct? Did we forget anything? Are there parts that contradict each other? Is this even possible to build?
This is your absolute last chance to catch those errors that are 100 times more expensive to fix later.
And that brings us to the final step, management. A project isn't a static thing. It's alive. Needs change, the market shifts, new ideas pop up. This step isn't about stopping change from happening. It's about controlling it. It's about making sure every little tweak is deliberate, understood, and properly folded into the plan.
Because an unmanaged change is never just one small thing, is it? It creates this massive ripple effect. It's a wave of chaos that can mess with everything from the initial design and the code, all the way down to the testing, the documentation, even the hardware you need. This is exactly how scope creep kills projects, one tiny, uncontrolled change at a time.
Okay, so that's the theory. That's the textbook version. But how does this stuff actually play out in the real world, with companies that we all use every single day? Let's take a look at how these principles are actually put into practice.
It doesn't really matter if a team uses a super traditional waterfall model where they try to plan out every single detail in one giant document up front, or if they use a modern agile approach like Spotify, where they work in these small, fast cycles and are constantly refining things. The core principles are exactly the same. They are still discovering needs, analyzing them, and validating them. The what never changes, only the how and when.
And a really key practice here is something called traceability. Basically, it means being able to draw a line from every single requirement to the piece of design it influenced, to the lines of code that built it, and to the test that proves it works. For places where the stakes are incredibly high, like NASA, this is completely non-negotiable. It's how they guarantee that not a single requirement gets left behind.
And really, that brings us right back to where we started. Putting in the effort to build a solid requirements process, well, it isn't just about dodging failure. It's about actively building the foundation you need for incredible, lasting success.
When you get that blueprint right from the start, the benefits are huge and they're real. You spend way less time and money fixing mistakes. You can actually develop and deliver faster. Your customers are happier because they're getting the thing they actually needed. And the entire process just becomes so much calmer and more predictable. No more chaos.
So I just want to leave you with this one final thought. We spend so much time celebrating the genius of coding, the actual act of construction. But the most beautiful, elegant code in the entire world is completely worthless if it's building the wrong thing. Coding builds the system, yes, but requirements engineering, that builds the foundation. And you and I both know what happens when you build on a weak foundation.